Hi guys, we're going to do exercise 5A from your methods textbook. We're looking at sketching the graphs of exponential functions. So the first one we want to sketch is y equals 2 to the power of x minus 1 plus 2. This comes from the basic graph of y equals 2 to the power of x. There it is there. We note that there are some important points there that we can put on. Negative 1, x is negative 1 and y is a half. When x is 0, y is 1, and when x is 1, y is 2. So let's think about how those would be changed when we go from y equals 2 to the power of x to y equals 2 to the power of x minus 1 plus 2. So the mapping of this graph will be your point xy becomes x plus 1. We get that from the x minus 1 in our index there, and y plus 2. So the graph is moving up 2 units and it's moving across 2 units to the right. Here it is here. So we've gone up 2, so now our asymptote would be at 2. And we move across 1 in the positive direction of the x-axis. So we want to put the new points in. So let's have a look. Where we have 0, 1, x would become 1 and y would become 3. Because in the original point, x was 0, y was 1. Now we map that to x plus 1, y plus 2, it comes 1, 3. The point 1, 2 maps to 2, 4 because x plus 1 or 1 plus 1 equals 2 and y plus 2 or 2 plus 2 equals 4. Finally, we have the point negative 1 and a half mapping onto 0 and 5 halves. So negative 1 plus 1, or x plus 1, is 0. Y plus 2, or half plus 2, gives us 5 on 2. So there's our new graph with the important features and 3 points labelled. Here's the asymptote at 2. Let's move on and try the graph of y equals negative 2 to the power of x. So by now you would know that that negative gives us a reflection. Here's the graph of 2 to the power of x. There are our points 0, 1, 1, 2 and negative 1 half. Now, when we map out from xy, we map to x, negative y. Remember that when it's a reflection on the x-axis, it affects the y values, so it becomes negative y. So that means that for the x values you put in, you just put negative for the y's. So 1 for x becomes 1 and negative 2 for y. Our point of 0, 1, the 0 stays the same, the y value of 1 becomes negative 1, so 0, negative 1. And lastly, our point of negative 1 half, that's going to become negative 1, negative a half. There it is there. It's the same sort of thing as when we do quadratics or cubic transformations. If you look at the steps, you can see how similar they are. Let's try this, where we have y equals 3 times 2 to the power of x. There's 2 to the power of x, as we know. There are our points that we've put in previously. Now, this 3 here is a dilation of a factor of 3 from the x-axis. That means that it affects the y values, so xy becomes x, 3y. Here it is here. Let's put the points on. Our point 1, 2 becomes 1, 6. Because 1 stays the same, x stays as x, and y becomes 3y. So 2 becomes 3 times 2, which is 6. Our point of 0, 1, x stays the same, so 0. Y becomes 3y, so 3. Our point of negative 1, a half, becomes negative 1 for x because it stays the same, and 3 times a half, which is 3 halves. There it is there. Let's try these ones here. So the first one we'll do is y equals 9 to the power of x on 2. So here's y equals 9 to the power of x, and here are some points, negative 1 and a ninth, 0 and 1, and 1 and 9. So notice I try and put negative 1, 0 and 1 for the points. Now here is a dilation of factor 2 from the y-axis. Watch out for that. It's the denominator in the fraction. So it becomes that our dilation is a factor 2 from the y-axis. So that means it affects our x values. xy becomes 2xy. So let's look at each of the points. -1 and 1/9, that turns into -2 and 1/9. Notice you've got to be careful that you affect the x values here, not the y's. The next one, 0, 1, becomes 0, 1 again, because, well, 2 times 0 is still 0, and y still stays the same. Lastly, we've got 1 and 9. Our x value is times by 2, the y value stays the same, so that becomes 2, 9. There it is there. And here's the graph with those important points labelled. Notice that we're not going to have an x-intercept, so we don't need to label an x-intercept. Our y-intercept is labelled. As long as your x and y-intercept's labelled, it doesn't matter what the other points are. However, -1, 0 and 1 from your original graph are good ones to do. Y equals 2 to the power of 3x is a dilation of factor a third from the y-axis. Notice how when we're dilating from the y-axis, that number is connected to the index there. Notice that when it's a whole number, it's a dilation of a third there. When it's a fraction, or it's in the denominator of the fraction, it means that it's going to be a dilation of a whole number. Now we want to sketch the graph of -2 to the power of x minus 1 minus 2. This is a combination of transformations. So let's think about the mapping that would take place with this. Here is y equals 2 to the power of x, our basic graph. The points -1, 0 and 1 are mapped in there. The mapping for this would be xy becomes x plus 1. I get that from up here where we have x minus 1 for our index. So x plus 1 and -y minus 2. We're going down 2 on the y-axis, and we've got a reflection. So there it is, there's our mapping. Let's have a look. Here, if I want to go step by step, I would say, well, here is -2 to the power of x. So we flip that over. I then have -2 to the power of x minus 1. So it moves to the left. It moves to the right, sorry, 1 point. 1. Finally, here is -2 to the power of x minus 1 minus 2. There it is there. It goes down 2 on the y-axis, across 1 on the x-axis to the right, and it is flipped. Our points, let's see what they become. 0, 1 would become 1 and -3, because 0 plus 1 for our x value is 1, and for our y value it's -y, so -1 minus 2, which is -3. The next value we would have there would be from the point 1, 2, which changes to 2 and -4. Let's see how that works. 1 plus 1 is 2 for our x value. 2 negative, made negative, so -2 minus 2 gives us -4 for our y value. Lastly, we've got -1 plus 1 for our x value being 0, and half being -half minus 2 gives us -5 on 2. So there it is. There's all our points there. And that's the end of 5A.